Hi everyone, welcome to this this video on lesson 17 of the sound and light scheme. This one is on color filters, and really it's building on what we covered last time, but where last time in the lesson on colors, the only two things that light was doing when it reached an object was either being absorbed or being reflected. When we think about color filters, it's not to do with absorption and reflection, it's to do with absorption and transmission. Otherwise, it's almost identical to what we saw in the previous lesson. And I think, again, it's one where it's a really nice one to teach. And the main thing is just get straight into the examples. You don't need to kind of go through loads of slides about what a filter is and so on and so forth. Get into the examples and show them how it works. That said, if you have filters, and most prep rooms will have some filters in there somewhere, absolutely, it's really important that before you do any drawing and before you are getting students to answer questions, that you are getting them to look through filters and see what color things appear, because having that concrete experience is going to make the diagrams that we draw now a lot clearer. So when I am teaching this, I would start actually with white objects. So I'm going to do a white piece of paper. I mean, my paper is not actually white, but I'm going to ask them to imagine it's white. And I just want to start by recapping what we did last time. So why does a white object appear to be white? Now again, I'm going to do the schematic diagram here for what's going on. So it's really important that students understand when I draw something like this, I'm talking about a beam of white light, or just white light in general coming from the sun or wherever else. I'm not talking about getting a red laser, a green laser, a blue laser with monochromatic light and shining each of them at the same time. I'm talking about white light. And if you need to do a kind of concrete to abstract thing and zoom in, that might be helpful. But for understanding what's going on with colours, in my experience, I found students find having it separated out a bit just makes things a bit clearer. So the first thing to do is just recap on what happens with a white object. And what happens is, when light reaches that object, all of the light, all of the different colours of light, I should say, are reflected. So I'm going to show this as follows. And I can draw these coming up here like that. So go up there like that. All of these are reflected. I've kind of gone upside down there. But that's fine, off here like this. So that's nothing new. That's what was covered last time. But what we can do now is introduce the idea of a colour filter. So what I'm going to do is say, and if you've got one to hand, that's even better. I'm going to say, right, now what I'm going to do is put a green filter in the way. So what happens, this is the question that I want students to think about, what's going to happen when light reaches that green filter? And I've just realised I might run out of room here, but hopefully it will be okay. And I'm going to label this as a green filter. Like this. And I want them to work out what's going to happen. And the point is, where before we were talking about absorption and reflection, now we're just talking about absorption and transmission. And again, one of the words that we need to explicitly teach students in this lesson is this idea of transparency. So a perfectly transparent material like glass, for example, would just let all colours of light through. That's perfectly transparent. Filters are semi-transparent. They let some colours of light through completely, other colours are absorbed. And in this case, I'm just going to model this directly to students. I'm not going to question them too much. I'm just going to tell them what a green filter does is it absorbs all of the blue light. It absorbs all of the green light, absorbs all of the red light, I beg your pardon, and it transmits all of the green light. I'm going to show that. I've just done that in a red pen, goodness me. It transmits all of the green light. So then I can draw my slightly weird looking eye again here, like that. So what are students, or what is this person going to see when a white piece of paper is viewed through a green filter? Well, it's going to see a green piece of paper. Now that is quite tricky for students to get their head round, and again, that's where having filters in the room with you, once you've gone through this, okay, this is what you'd expect to happen. Now look at your book, at the white paper in your book, through a green filter, what you would hope is that they see that it's green and they can then explain what's going on. So you can do similar examples with different coloured filters. That's absolutely fine. Now let's think next about what's going to happen with another object. So this time I will do a red tomato, just like we did before. So I'm thinking a perfectly red object, something that looks like this. So if I've got a perfectly red tomato, first thing I can do is say, I could say what's, in fact, sorry, start again. First thing I'm going to do is recap on what we covered last time. Why does that object appear to be red? The reason it appears to be red is because red light is reflected, but all of the green and the blue light are absorbed. Now, one question you can ask is, say, well, if I viewed this through a red filter, what colour would it appear? Well, all of that red light is going to pass through the red filter. So I could draw my red filter here. My red filter. All of the red light is going to pass through, will be transmitted. So it would appear still to be red. Nothing too surprising there. What about if I viewed this object through my green filter, however? So let's now draw green filter, and I can use the same label here, like this. That's a green filter, as I drew before. Now, what students need to recognise is that even though there's no green light arriving, that doesn't mean the red light is going to pass through. As we saw in the previous example, what green filters do is they absorb all the red, they absorb all the blue, they transmit all the green. So what have I got here? Well, I've only got red, because the green and the blue got absorbed by the tomato. So actually what's going to happen here is my red is going to be absorbed. That's weird. So no light is going to reach the eye. Now what you want students to recognise is, if no light is reaching the eye, then actually when I view my red tomato through a green filter, that red tomato is going to appear to be black. So that's where it gets really tricky, or it's not the trickiest, but that's where it gets a little bit tricky, because students have to recognise that if no light is able to pass through the filters and no light reaches the eye, then the object's going to appear black. And for, just to illustrate that example again, even with our perfectly white piece of paper, like this, so even if all of the light is reflected, as in this case, let's draw these three again, and I'll draw them coming up like that. Oops. This is my piece of paper. Essentially what you want students to recognise is that any combination of filters, if they're perfectly red, perfectly green, perfectly blue, any combination of filters is going to lead to all of your light being filtered out. So if that's a blue filter, well, that's only going to transmit the blue. The green and the red are going to be filtered out. So only the blue is transmitted. But then if I combine that with, let's say, a red filter, that same label here, a red filter, well, the blue is going to be absorbed, there's no red to be transmitted, there's no green to be absorbed, essentially nothing gets through. So even that white piece of paper, when viewed through two filters, would appear to be black. Now, again, why do students need to learn about this? What is the value of this? I think I think it's kind of interesting. Most students will have used some sort of software that mimics filters on Instagram or another social media platform, or on their phones or whatever. So you can kind of explain to them that this is how it's working. It's just a digital electronic way of doing that using software. Obviously, they will have come across sunglasses and maybe have seen even coloured contact lenses and things like that sort of thing. But really, in terms of the, how important is this for them to understand how this works in everyday life? Probably not that important. But remember, what this is a really good opportunity for students to do is to just practice that logical deductive thinking. If I introduced a blue filter, what would I expect to happen? If I introduced a red filter, what would I expect to happen? And then if you've got the filters in the classroom with you, it's also a really good opportunity to not just do that deduction phase, okay, what would I expect to happen given my model of light that I'm working with. You can also then check it and say, well, okay, is that what you observe? So let's put a red and a blue filter together. Let's look at a piece of paper and see whether it appears black as we would expect. And you might find that it doesn't, and then you can that's a nice way into all sorts of other questions about, well, why doesn't it appear black? Well, maybe these blue filters aren't actually filtering out all of the red and green light. Maybe they're allowing some through, and the same for the red filters with the other two colors. So lots and lots of interesting questions that you can explore here, and just by drawing these diagrams and getting students to think in terms of this model of light as being made up of lots of different colors, that's what's going to be really valuable to deepening their understanding of light. I will do a second video for this lesson on the slightly more complicated colors. Yeah, that again will be only for the intrepid teachers and the ambitious students who really want to push themselves above and beyond. So there will be a second video. If you don't want to do that with your group, you can skip on to the next video, which will be the final video for this scheme on the electromagnetic spectrum.